Look, Spencer, there's a subtraction sign in there. If there was an addition sign or subtraction sign, can I just square this? No, that'd be breaking the forbidden rule. How do I need to rewrite this? Times 2x minus 3. I'm going to ask, because I know there's people out there that still do not know how to do that on the first test. They didn't know how to do it on the retest. Okay, so now looking at this, what are we going to do from here? Distribute. Now carefully, everybody, some of you still get the right idea. You're like, I need to distribute, but then you're making errors distributing. Watch with me. We're going to take 2x. We need to multiply both through to this term and this term. So let's start here. 2x times 2x. 4x squared. Guess what? So many of you are forgetting the squared on that. Not good. 2x times negative 3. Negative 6x. Very good. I distributed my 2x term. Questions? I'm not done. I need to distribute negative 3 through to each term over here. Negative 3 times 2x. Negative 6x. Negative 6x again. And then negative 3 times negative 3. Positive 9. Good. Positive 9. Now, most of you are getting good at seeing, okay, I'm going to combine like terms. 4x squared, there's no other x squared. And then a lot of you are getting better at not just looking at that and saying it cancels, but thinking about it. Negative 6x's minus 6 more x's leaves me with how many x's? Negative 12x. Good. Negative 12 x's. You guys are getting so much better. And then plus 9. Now, can I combine these two things? No, those aren't like terms, so this would be our final answer. How many of you got it right? Awesome. That's awesome. This class did way better than my last class then. Okay, very good. It's been a few weeks since we've seen that. You'll see it throughout the year. All right. So now we're going to get started. Now I need you to understand something. You'll want to take notes. You need your calculators out. I'm going to be honest. I'm not just saying this. This is one of the harder lessons of the year. Okay? I taught it to my class last year towards the end of the year because we were on similar polygons towards the end. So their brains had developed way more advanced, and it was still one of the hardest lessons of the year. Now, first hour, really hard for them. Now, usually my first hour class gets it like that. So you're going to need to focus today, ask questions today, because it's a hard lesson. I'm telling you, it is. Okay? So you need to ask questions, focus. Do not let yourself zone out. This would be the one lesson of the year to not zone out on, because it's going to be kind of hard. Okay. So what we've been doing in this unit, understand something. What we've been doing in this unit is dealing with similar polygons and similar triangles. Now we know a few things about similar polygons and triangles. First things first, they'll have the exact same number of sides. That one makes sense. Second thing, all the angles will be what? Tell me. Equal. All the angles will be exactly equal. Even if you have a small triangle and a huge triangle, the angles will be equal. And then the third thing and the most important thing that we've been dealing with, if we have similar triangles, then we can set up a ratio of corresponding sides and solve for x, right? We can set up a ratio of corresponding sides. Now, when I say corresponding, I mean it sits in the exact same spot on the triangle, but on the exact same spot on the two different triangles. Does everybody understand that, how corresponding works? They sit in the same spot, but on different triangles. Are you with me? Some of you are already like, I just don't know. Did that make sense of what I just said? Yeah. Okay, we've already learned that, right? Okay. So that's not any different than what we're doing today. That's not any different than what we're doing today. But we're going to apply it differently. So this time we're going to be given a right triangle. Now we haven't been really given a right triangle yet before. And if we take a right triangle, now guys, understand something. What makes it a right triangle is this 90-degree angle. So if I was to erase that blue line, does everybody see this huge right triangle here? Yes. Okay. So I have a right triangle. Now if we take a line, an altitude, and drop it straight down from the right angle of the right triangle, making a perpendicular line, dropping it perpendicular, that means it makes two more 90 degrees right here. Dropping it perpendicular means it makes it 90 degrees. Then what happens, guys, is we have three new similar triangles, okay? So everybody look up here. We have three similar triangles because we have this small right triangle. Does everybody see the small right triangle? Yes. And then we have a medium-sized right triangle. Does everybody see it? Yes. And then we have the large right triangle. Does everybody see those three similar right triangles? Yes. Okay. So with that being said, this altitude being dropped down creates a geometric mean. I'm going to explain in the next slide what it means. But how this geometric mean happens is you'll set it up like this. I'll explain why in the next slide. It has to do with similar triangles. but this is just something to know for right now. A geometric mean, you'll take H1 over A will be equal to A over H2. So this is a ratio we'll set up. And it's due to corresponding sides in similar triangles. I'm going to explain in the next slide. Okay? So just understand though. Notice, like this works in kind of a pattern. I did H1 over A is equal to A over H2. Does everybody see how it kind of worked in making like a triangle? So H1 over A is equal to A over H2. Good. So this geometric means it happens because we're dealing with two similar triangles. Three, but the geometric means happens on the small triangle and the medium triangle. And here's why. Okay, so everybody listen. When you drop the altitude on the small triangle, so I'm going to highlight that for right now. On the small triangle, the altitude will always be the long leg. Now I'm going to use a couple of words today. I'm going to use hypotenuse. Hypotenuse is across from the 90-degree angle, right, everybody? Then there's going to be a long leg, and there's going to be a short leg. So once again, hypotenuse, short leg, long leg. Okay, so on this small triangle right here, this altitude is going to be the long leg. Now over here is the hypotenuse, right? But that A is going to be the long leg of your small triangle. Now look with me on our medium triangle. The A on the medium-sized triangle is going to be your short leg. And right here's my hypotenuse on the medium triangle. Does everybody see that? So if I took those triangles and split them apart, they'd look like this. Our A is our long side on our small triangle, right? So H1 must be the short side. And then on our medium triangle, we know that A is our short side and H2 is our long side. All right. So with that, we know that we can set up ratios of corresponding sides. So we would do H1 over H1 over A is equal to A over H2. So that's why that happens. Okay. Now, if you understand that little trick I taught you, just looking in the triangle, in the pattern of a triangle, it's almost easier. H1 over A is equal to A over H2. That's almost easier, but I just wanted to show you why. It's because we have similar triangles. All right. Now, I understand that that's a little bit fuzzy still. It's going to get better. Okay, now here are the very important things. Now, if you want to take a picture of this, that's what I would do because you're going to use it. Okay, so what we're going to be doing is we're going to be splitting these triangles up because we have three similar right triangles. And then once you've gotten it split up, that's the hardest part. You know you can set up a ratio of corresponding sides. So everybody, we have a large triangle, a medium-sized triangle, and a small triangle. Three similar right triangles. Does everybody see the huge, large triangle here? Yes. Okay, now right here's the 90 degrees. Am I correct? Yes. So across from that would be the hypotenuse. So the hypotenuse would be that entire length, right? Yeah. So that would be H1 plus H2. Right? Yeah. Okay. Questions on that? Okay. Now. Yes. Yep. Good. Yep, it would be. And then, so Jess just asked a good question. Would H1 plus H2 always be the hypotenuse of the huge triangle? Yes. Okay, now look at our medium-sized triangle. That's this one right here. Our A is our short side, right? Our A is our short side of that medium triangle. So H2 must be the long side. And then across from the 90-degree angle would be right there, and that's our hypotenuse. So I'm setting these up the same way. Now on the small triangle, our altitude is always our longest side, right? Right. So H1 is our shorter side, and then the hypotenuse will be across from that, so it would be right there. Now I did not split it up with the other class, and holy cow, I'm going to try a different approach to teaching this today because they did not get it. So I am going to try splitting up every single triangle like this because then it's easy. Couldn't we set up the ratio of corresponding sides very easily looking at this? This side corresponds to this side, right? This side corresponds to this side, right? The hypotenuse corresponds to the hypotenuse. So I'm hoping that'll be better. All right. Are you ready to practice? So vocabulary, hypotenuse, long leg, short leg. Good. And then there's a huge triangle, a medium, and a small. Okay, very good. Here's our, okay. So let's practice finding the geometric mean of these two numbers. So this was on the triangle, this is on the triangle. If this was x and this was 14 and 10, we would set it up like this. 14 over x is equal to x over 10, right? Yep. So you'll just set up your blank thing like this if you're asked to find the geometric mean of the two numbers. This is a little trick I taught you, right? So you'll set up your blank slate like this. Blank over x is equal to x over blank, and then you'll insert your two numbers. Your triangle will look like this, but you're not always going to be given the triangle. So you do 14 and 10. Now let's solve. Let's solve. Now once again, that happened because we did 14 over x is equal to x over 10, right? Okay. Now we'll cross multiply and solve. So watch. We multiply both sides by 10, but what happens on this side? It divides out. Very good. We multiply both sides by x because it was on bottom, and this side it divides out. 10 times 14. So 140 is equal to x times x is x squared. Now remember, you guys should know how to do this. If you're given an x squared problem and it's just simply x squared, you can solve for x by taking the square root. So we've got to take we're trying to solve for x, so we'll take the square root of both sides of the equation. Now when you do that, our root cancels out with our power, leaving us with x, which is what we want. Today I'm okay with decimals, so take the square root of 140 in your calculator. Pull it out so I can show you how to type that in. Okay, pull it out. If I can find it. There. So you'll type it in like this. So you'll do that. So you'll go second, the second key, and then down to, see where it says x squared? Now notice above it, it says the square root. So you'll hit the second key, then square root, and you'll type in 140. Close your parentheses, hit enter. 11.8. Now we'll round to one decimal place today. 11.8. Did everybody see how to do that? You're going to be using that a lot today. Okay. Okay. We get x is equal to 11.8. That was the geometric mean. Okay, so now once again, on the problems, I'm going to have you do 1 through 6. Set up your blank thing. You'll do blank over x is equal to x over blank. Insert your two numbers and cross multiply, right? So do problems 1 through 6, go. So I'm going to do number 1. It says find the geometric mean. We know that if we had a right triangle, we would do that little trick I taught you, but we weren't given it. So we'll set up the same thing we would do if we had the triangle. We would do blank over x is equal to x over blank, and you'll insert your two numbers. So 32 and 8. So then we would, from there, cross multiply both sides by 8, but it divides out over here. Multiply both sides by x, but it divides out over here. So 8 times 32, 256. So we have 256 is equal to x squared, and then what would we do? Square root both sides of the equation, and we get 16 is equal to x. Our geometric mean is 16. Okay, finish problems 1 through 6, and then all right. Okay, so we're moving on. You're understanding how geometric mean works. Let's get to the good problems, okay? Now, honestly, the best way for you to understand this stuff is just to go through it by example. We're not using anything new. We will know that if we have similar triangles, we can set up a ratio of corresponding sides and solve for the variable. So looking at this, guys, looking at this, we have this huge right triangle. We're asked to solve for x. Now notice, these are my two 90-degree angles right down here. Now, the first thing I always look for is, do I have enough information to use my geometric mean to be able to solve for x? If so, I'm going to do that because I know a little trick to make it quicker. So looking at this is my straight line with my h1 and my h2, right? And then this is my altitude, right? So couldn't we just go ahead and use that little geometric mean thing we just learned? 5 over x is equal to x over 40. So 5 over x is equal to x over 40.
How do you know which one to put on top or bottom?
It won't matter, actually. Great question, yeah. So we could have gone the other way and done 40. Great question. It was a good question. Other people were wondering that same thing. You could have also done 40 over x is equal to x over 5. Good question. All right, so now let's cross multiply and solve for x. I'm going to multiply both sides by 40, but on this side it divides out. I'm going to multiply both sides by x since it's in the denominator, but on this side it divides out. 40 times 5. 200 is equal to x times x is x squared. questions? Now we take the square root of both sides since we need it to be x. And then our root cancels out our power. So we get x is equal to 14.1. Okay, that one wasn't bad, right?
Why can't you just times the 5 by the 40 by the square root?
That's what you're doing. It's just you're setting up the algebra behind it because it's not always going to be like if you set up the algebra, you won't make an error, right? That's exactly what we did. We just did the algebra behind it.
But 5 times 40 squared is pretty awesome.
I mean, you're doing the math, skipping the math because you're seeing how to do it, and that's fine because you're still doing the math. Okay. All right, so looking at this one, it says solve for x. Now, first of all, look at it carefully. Can we use our geometric mean? Do we have enough information? No. It would be 9 over, we don't know, over we don't know over x. That's not going to help us. So this one, we cannot use our geometric mean. But we have a bunch of similar right triangles here. Now, in my other class, I did not split up the triangles. I'm going to try that to see if it makes more sense. Because honestly, it didn't make sense the last hour. So looking at this, guys, we have this small triangle, right? Do you see it?
Yes.
Okay, so I'm going to draw a very small triangle. It's a right triangle. All right. That's kind of small. Maybe I should draw a little bigger. Okay, so I have my small right triangle. Now, across from the 90 degrees is what? 15. So across from the 90 degrees is 15. Now, this altitude on my small triangle, this altitude is the long leg, right?
Right.
So this 9 is my short leg. So this is going to be my short leg. We don't know the long leg, so that's as much as I'm going to put. Did that make sense?
Yeah.
Okay, now we have a medium triangle here. So I'm going to draw a medium size. On my medium sized triangle, do we have the hypotenuse?
No.
No. Look across from the 90. Nothing. We know the altitude is the small leg on the medium triangle, right? So this x is the long leg. So x is going to go there. And then do we know the short leg? No. So that's all we've got on the medium triangle. Then we also have our huge, large triangle. I know this is going to make more sense. So we have our huge, large, huge triangle here. Does everybody see it?
Yes.
Across from the 90 degrees is what?
9 plus x.
9 plus x. So our hypotenuse will be 9 plus x. Yeah?
Right.
Questions on that piece? Then on my huge, large triangle, 15 is the smaller side, right?
Right.
So on this, my smaller side's been on bottom, right? So that's 15. Does everybody see my 3 similar right triangles?
Yes.
Now that we split it up, the hardest part was that we can set up a ratio of corresponding sides to solve. Okay, so looking at this, I'm going to use this triangle and this triangle because don't we have corresponding sides on both?
Yes.
So let's set up a ratio of corresponding sides. 15 over hypotenuse over hypotenuse, so 15 over 9 plus x is equal to 9 over 15. Now to solve for x, we'll cross multiply and solve, right?
Right.
So I multiply, everybody, but before I actually do that, are we all okay on how I did that? No, not okay. Okay, let me say it again. Does everybody get how we got to these 3 triangles?
Yes.
Okay. So then we know that with similar triangles, we can set up a ratio of corresponding sides. So 15 is the hypotenuse. 9 plus x is the hypotenuse. Those are corresponding sides. So I said 15 over 9 plus x. Those are corresponding sides. And then I started with the small triangle, so I got to stay consistent, is equal to 9 over this side on that big triangle was 15, so 9 over 15. That's how you set up ratios of corresponding sides. Now we'll cross multiply and solve for x. So I'm going to multiply both sides by 15. It divides out on this side. Multiply both sides by 9 plus x. It divides out on this side, right?
Right.
Don't double dip. 15 times 15. 225 is equal to, do I need to put this in parentheses? Yes, right?
Yes.
So 9 plus x. Let's distribute it through. 9 times 9 is 81. 9 times x
Got it.
plus 9x. And now solve for x piece by piece.
Minus 81.
Minus 81 from both sides of the equation.
144.
So 144 is equal to 9x, and then what? Divide both sides by 9. So x is equal to 16. Questions? Okay, let's do another one. A little bit harder. It will get easier though. Okay, looking at this one, it says solve for x and z. So we have our huge right triangle, our small right triangle, and our medium right triangle. Well, first of all, I always look to see if I can solve using a geometric mean. Can we solve for z easily?
Yes.
Yes, we can use our geometric mean and solve for z. So 3 over z is equal to z over 4. Questions on using that geometric mean? So then we'll cross multiply both sides by 4, but it divides out over here. Multiply both sides by z, but it divides out over here. So we have 4 times 3, which is 12, which is equal to z squared. Then we'll take the square root of both sides of the equation, so that our root cancels out with our power, giving us z is equal to 3.5. Okay, we found z. Okay. Questions on that part? Yeah. It's a fancy z.
It's a 7 and a 2.
7 and if you turn it sideways.
Yeah.
Yes, very good looking. All right, so let's find x. Let's find x. Now, I am going to split these 3 triangles up. So z is 3.5. Was that the whole decimal? Okay, so just understand, if you use the 3.5, that rounded answer, to calculate another value, to find another value, you've got to use the full decimal. Otherwise, your rounding will be off. So you can round final answers, but you can't, if you're using that value to solve for x, you won't be able to use 3.5. You've got to use the full decimal. But I would just choose not to use that side. Okay, so let's set up our 3 triangles. We have our small right triangle, and we have our medium-sized right triangle. We have our large right triangle, right? Right.
Right.
Guys, this is the hard part, so you need to be with me. Okay. So on my small triangle, right here, on my small triangle. Now the reason I knew this was small is 3 smaller than 4.
Yes.
Okay, so this is my small triangle. So focus in here. What's my hypotenuse?
X.
X. What is my short side? 3.5, which we won't use if possible. And then what's my long side? Short. That's my long side. This is my short side, right? So my short side is 3. Questions on that? Okay, I'm going to color code it. Let's go to the medium one. What's my hypotenuse? Don't know. And what's my short side?
3.5.
Now that's down here, right?
Right.
3.5. What's my long side? 4. Now on my huge, large, very large triangle here, what's my hypotenuse?
7.
3 plus 4, which is 7. Does everybody see how the hypotenuse is 7 on the huge triangle? Okay. What is on the huge triangle? What's my short leg? X. Do we know the long leg? No. Okay. So now we're trying to solve for x. Let's set up a ratio of corresponding sides. Which triangle has a hypotenuse and a short side? The very large and the very small. So let's set up ratios of corresponding sides. So sorry, let's go with this one, small to big. So x over 7 is equal to 3 over x. Yeah, this one happened to be. Now, because x and x are the same variable, we're good, we can solve. We cross multiply by 7, but it divides out over here. We cross multiply by x, but it divides out over here. So we have x squared is equal to 21, right? Are we following? People, are we following? Take the square root of both sides. So we get x is equal to 4.6. Does it round up? 4.6. Very good. Okay. Okay, questions on that? Yeah.
So what I don't get is like the second factor. So it would be like displayed is the 1 and 3.5 on the huge version 4 on the bottom, and then displayed for now.
So you mean like if this is x is 4.6, right? Right here? Okay. So sorry. So you're saying, does this picture make sense?
Well, like 1 and the 3.5 of the 4 would be the same if they were switched their count.
No, because.
Short.
But why are you switching them? Is my question.
Because it just looks like
No, that wouldn't be the same. Because remember that that's a great question. Now I'm catching it. Remember the altitude on the medium triangle is the smaller leg, right? Right? So that would have to be the smaller leg out of the 3.5 and the 4. Hopefully I answered that correctly. Okay, let's do another one. Yeah, you guys, it's kind of hard. It takes some depth of knowledge. Like, you have to really think about these. Let's do another one. Okay? I'm going to show you 2 more examples, and I'm going to let you work. But you need to stay with me and not let yourselves zone out. Okay? Because they're going to get harder and harder. And we're testing on this Thursday. So, here we go. Solve for x, y, and z. Solve for x, y, and z. So this one's the trickiest one so far. Now, first thing I always look for, do I have a geometric mean that I can use to solve? 1 over y is equal to y over x, right?
Yes.
Do we have 2 different variables?
Yes.
So there's no way to solve, right?
Yes.
Okay. So we can't use our geometric mean on this one. So let's move on to a different one. So we know we have to use similar triangles. So I'm going to draw them in again, and it's helping. I think you guys are getting it better than the other class. So we have our small triangle, our medium right triangle, and our large right triangle. Is everybody following? Yeah? Yeah. Okay. On my small triangle, what's my hypotenuse? 2. Questions. What's my small leg? 1. Remember, y is definitely the large leg on that, so we have a y over 1. Questions on that? So I'm going to change colors. Let's look at our medium triangle here. What's our hypotenuse? Z. What is our short leg?
Y.
Y. Short legs go down here. And then what's our long leg? Now let's look at our huge, large triangle. What's my hypotenuse?
X plus 1. Yeah, x plus 1.
Yep, x plus 1, 1 plus x. Same thing. Yeah, good. That whole length, so that'd be 1 plus x. Questions on how the hypotenuse on the huge thing is 1 plus x. Okay, what's my long leg on it?
Z.
Z. And what's my short leg?
2.
2. Questions. Now we have some set of ratios. There's no set of a ratio with 2 different variables. That'd be that. So looking at this, I have this 2 and 1. I know I'm not going to have to really worry about 2 different variables if I look at this smartly. So I'm going to use this small one, and I'm going to go with hypotenuse. So 2 over, what is another hypotenuse that we need to solve? Let's solve for x. So hypotenuse over 1 plus x, or x plus 1, same thing, yep, is equal to short, which is 1, over what's the short over here?
2.
2. Do I have more than 1 variable?
No.
No. So we can cross multiply and solve for x. Questions on how I did that? Now, if we got to 2 variables, we'd be like, okay, let's try a different ratio, right?
Right.
Cross multiply both sides by 2, but it divides out over here. Multiply both sides by 1 plus x, but it divides out over here. 2 times 2 is?
4.
4. So we have 4 is equal to 1 distributed through would be 1 plus 1 plus x, 1 plus 1x. Now to solve for x, what would I do?
Minus 1.
Minus 1 from both sides of the equation. 4 minus 1 is?
X equals 3.
So x equals 3, 3 equals x. We know x is 3. Now can we use that? That wasn't a decimal. It was an exact value. Let's use it. So now our hypotenuse is 1 plus x, which is 1 plus 3, which is?
4.
So our hypotenuse is 4. Now we have a lot more information we can use. So let's set up ratios of corresponding sides, not having 2 variables. Oh, and we know x is right here is what?
3.
3. So we know that's 3 right there. Okay, so let's set up ratio of corresponding sides. I'm going to go with, let's go with this one. Let's solve for y. So let's do y over what? Y over 3 is equal to, let's go with 1 over y. Do we have more than one different variable?
No.
We have the same variable, so we're good. We can cross multiply and solve. Question on how I got that part. Okay, cross multiply both sides by y, divides on over here, multiply both sides by 3, divides out, so we have y squared is equal to 3, square root it, and we get y is equal to 1.7. Because I just can do it in my head. Just
Check the math degree.
I
This
just,
is a math.
yeah, that's why. Okay. So y is equal to 1.7. Now we won't use that unless we want to use the full decimal to calculate. So I'm not going to choose to use that side as a ratio. Okay, now our last one is solving for z, right? So we have to use this large, huge triangle, right? Or the medium triangle. Okay. So do you want to go with the larger or the medium? Okay. So z is the long over, which one do we have an answer for the long?
3.
Yep, 3. Okay, so z over 3. So you're going with this one and this one is equal to, let's go with this, well, either way we're going to have to, if we use,
4 over z.
is equal to what?
4 over z.
4 over z, that's a good one. Yeah, so hypotenuse over hypotenuse, right?
Right.
Okay. 4 over z. So we went with z over 3 is to 4 over z. Did everybody see how we set up the ratio and corresponding sides? Well, it sure means not really. So yes or no?
Yeah.
Are we good? Thumbs up, people.
Okay.
Okay. Well, if they don't really get it, they need to speak up. Okay. So cross multiply. We'll have z squared. Multiply both sides by z. We'll have z squared is equal to what?
12.
12. So then square root both sides.
3.4.
3.4. So z is equal to 3.4.
Really?
I don't know. I just went with what you said.
Oh, I guess. Is it really? Oh my god.
3.5 if we round. Right? Very good.
Okay.
Is it if we round?
Yeah.
Awesome. Okay, guys, last one that I'm going to let you work. This one's quick. Okay, looking at this one. Says solve for x. Can we solve using our geometric mean?
Yes. Yeah.
Yep. We got to do in the correct order. 2 over 3 is equal to 3 over x. So 2 over 3 is equal to 3 over x. Now we'll cross multiply. So multiply both sides by x, but it divides out over here. Multiply both sides by 3. Divides out. So we have 2x is equal to 9. Divide both sides by 2. So x is equal to 4.5. Yay. I'm writing sides. Okay, questions. If you have to redraw the triangles, do it. Okay, I think that made more sense to you guys than it did first hour without splitting it up. Okay, so do problem 7 through 20. I want you working your tail off on this stuff.
Well, they don't have tails.
You do.
Oh.